EUREKA online, where we put you through on your subject and courses. Where we put you through on your subject and courses. Physics, chemistry, biology, and all science courses or subjects that you're offering. This is what we put you through. So the best tutorial will explain everything to you. It is. So we're going to take some examples of function. We're going to take some examples of function. So I told you that we have what we call domain. Okay, before then, for someone to be perfect in solving question on domain, he or she must know these three terms. These three terms we have defined numbers, we have undefined numbers. We have defined number, we have complex numbers. Okay? So a defined number are a number that is continuous. Defined number are a number that is continuous. Defined number are a number that is continuous. Defined number are a number that is discontinuous. That is discontinuous. Okay? So it has two conditions. It has two conditions. The first condition is that when we have R2 over R1, when we have R2 over R1, provided that R1 is not equal to 0. So if R1 is not equal to 0, we say it is defined. R2 can be 0. But if R1 is not equal to 0, we say it is defined. So what is now our R? R is real numbers. So there are some number we call real number, while there are some number we call integer number, there are some number we call natural number, and so on. So, but in domain we consider real number and integer mostly. Real number, integer, and complex number mostly. Real number, integer, and complex number. So, integer number are number that are whole number. I've said it in one of the video before. So integer are whole numbers, that are not decimals. Examples are, you can have a 0, 1, 2, 3, 4 to infinity. You can also have minus 1, minus 2, minus 3, minus 4, minus 5 to minus infinity. So you can see that means we have two types of integer. Don't forget that it is because we need it in this defined operation. That's why we are defined number. That's why we are trying to explain them. So we have that means integer have two types. We have a positive integer. So we denote it with Z plus. So integer is denoted with Z, while positive integer is denoted with Z plus. So we can also have it this way. Z, we can put the plus and the subscript here. So I'll put it as a power. We can also have negative integer. So the positive integer, the example is this 0, 1, 2, 3, 4 to infinity. So we have a negative integer. So we have a Z minus or Z minus. So you can have it as a subscript. can have it as a subscript. We have a Z. So we have a Z, not 2, but Z. Z minus Z plus. So now, if we usually substitute integer to get our domain. We usually substitute integer. So that means we also have what we call real numbers. Real numbers are numbers that comprises of integer and whole numbers. It comprises of integer and whole number. And it is denoted by R. It is denoted by R. So that means since real number comprises of whole number and decimal, that means integer is a subset of what? Of real number. So real number it's a superset of integer because integer can be found in a real number. So because of that, when we say real number, we are indirectly talking about integer inclusive. Integer inclusive. So if R is not equal to 0, since we know that since we know that 0 is a real number, then we can just say that we are having defined numbers. For example, if we have 1 over 2 is defined, which is 0.5. If we have 2 over 3, we have 4 over 8. We have 8 over 4. So all these are defined. That's what we are trying to represent here. But also we can also have the second condition for we to have a defined number. Second condition is square root of positive range. Square root of positive range. So the real number must be positive. The real number must be positive. So when we have square root of positive real number, it's not going to give us undefined. Rather, it will be defined. And when it define like this, then it means that the value is substituted to make the function defined. It's the domain of that function. It's the domain of that function. So we can also have undefined number. Undefined number are continuous. Number that continue. Number that continue are undefined number. Number that continue are undefined number. Number that continue are undefined number. Number that is continuous. So number that is continuous is undefined. It also has two conditions. Anytime we are having real number over 0, either 0 over 0, provided the 0 is at the denominator, we say it's what? Undefined. Okay, sometimes we just simplify the denominator, we get 0. So that value is substituted that makes the denominator to be 0 is not a domain of the function. So we can also have square root of negative real number. It's also undefined. So that is just about defined and undefined number. So we can also have complex number. A complex number is a number that has two parts. A complex number is a number that has two parts. That is the real part and the imaginary part. A complex number is a number that has two parts. That is the real part and imaginary part. So we denote a complex number with this kind of symbol. Or sometimes we can use Z for complex number. Okay? So it's a number that has two parts. So we can just say that C is equals to, this symbol is equals to A plus IB. So A plus IB, whereby our A is equals to real part, and our IB is equals to imaginary part, while our I is equals to imaginary unit. So I is equal to imaginary unit. So look at this kind of situation whereby we have square root of minus 4. If you have square root, I'm still dealing with complex number. So square root of minus 4. Square root of minus 4, someone will just say it's 2. No, it's not. That means you can easily see we have a square root of minus 1 times 4. We have not affected anything. We have not affected the stuff. Rather than, you know that minus 1 times 4 is equal to minus 4. So that means we can break this. When we break it, according to law of sort, when 2, 3, 4 terms and multiply each other, or values and multiply each other, or variable in a root, we can easily break the roots so that each of them is separated. So you can say we have square root of minus 1 and square root of 4. So in mathematics, there's a relationship. Square root of minus 1 equals to I. Yes, it's equals to I, where I is imaginary. Yes, okay? So that means square root of 4 is now 2. So that means square root of minus 4 equals to what? Square root of minus 4 equals to 2I, or I2, depending on what you wish. So though values or number usually come before alphabet. Values or number usually come before alphabet. So that is just defined number or defined number, complex number. So if anytime we have a complex number, that means it's not defined. Anytime we have a complex number, that means it's not defined. And we usually use infinity for undefined. We usually use infinity for undefined. Use infinity for undefined. So let's take some example under domain. Some example under domain. So the example we are going to take now is let's assume we have a y equals to 2s plus 8s squared minus 1. Okay? So if we, this is non-restricted domain because we are not given any value to substitute. Rather, we are going to test with our own values. We test with the integer, positive integer, and the negative integer. So we now say when we have started solving it, when s equals to 0, test with the positive s, we have a y equals to 2 into 0 plus 8 into 0 squared minus 1. So y equals to minus 1. So this is defined. So this value 0 that we put here that make it defined is our domain. 0 is the domain. It's not the result of God that is our domain. But the result should point us to our operation that we are having 0 as the domain of this function. So in that, we can also test when s equals to 1. We can also test when s equals to 1. In that case, we are going to be testing the positive integer. When we are done, we test the negative integer. But you know, we can't continue. We can easily judge it when we get to some point and say, okay, there's no value we can put here that will make it defined or undefined. So we now stop. Okay? So when we put 1, our y is equal to 2 into 1, plus 8 into 1 squared minus 1. So we have a y is equal to 10 minus 1, y is equal to 9. So it's also defined. So since it's defined, let's test 2. I think that's where we stop. Test 2. Because there's no value we're going to put here that make this function defined. No value we're going to put here that make this function defined. There's no value. So we just say when s equals to 2. So when s equals to 2, we have a y is equals to 2 into 2 plus 8 into 2 squared minus 1. So which gives us y equals to 4 plus, this is 32 minus 1. So y is equal to what? 35. It's also defined. So we are going to test the negative values. We take the negative, we use the negative integers to test it. We use the negative integers to test it. So y is equal to 2 into minus 1 plus 8 into minus 1 square minus 1. So we know that y is equal to minus 2 plus 8 minus 1. So y is equal to y is equal to what? Y is equal to 5. Y is equal to 5. So in this kind of situation, you see it's what? In the range of the function. So we can make our conclusion using three ways. We can make our conclusion using